Mr. Lucier's chemistry!
Good morning, everybody. Welcome back to chemistry. Today we're going to be talking about acids and pH. But before we get started with that, let's do a quick recap. Last video you watched, it talked about the pH scale. And you learned that anything lower than 7 is acidic. Anything greater than 7 is basic or alkaline. And if you got 7 exactly, then that is what we call neutral. So that means the more acidic you are, the more H+ ions are in solution. The more basic you are, the more hydroxide ions are in solution. So we're kind of sticking with the Arrhenius method here. Don't forget that this H+, the hydrogen ions, we also call them protons, and hydronium, H3O+. So those are the three ways you'll see acidic: H+, the protons, or hydronium. It's all meaning the same thing. So that's what you learned last time. So we're going to pick up from there, and we're going to talk about acids and how it relates to pH. Now, what we're talking about here is concentration. Remember, concentration, we look at how many H+'s are in solution. And we measure concentration, moles of H+'s to total liters, and that's in molarity. So the unit for concentration is molarity, but what we're actually measuring is the total amount of protons or hydronium ions in solution. So that's concentration. Now another way they show concentration is to put brackets around something. Okay, so if you see brackets, that means concentration. And so to be more specific, what you'll see is the H+ with brackets in it, or you will see the hydronium, H3O+ with brackets in it. Either case, they're talking about how much hydrogen is in solution, because we're talking about concentration here. How does concentration relate to pH? Really, what pH is measuring is how many hydrogen ions are in solution. So really, pH is an offshoot of concentration. So there's got to be a way to convert between pH and concentration, and there is. If you take the negative log of the hydrogen concentration in molarity, that's going to get you pH. Take the negative log of the hydrogen concentration in molarity, and that gets you your pH. And at the same time, if you want to go back to concentration from pH, you're going to go 10 to the negative pH, and that's going to give you back your concentration. We're going to do some examples just to show you how these calculations work. So let's go over some examples. Here's example 1. Let's say I have a pH of 2.5. Well, if I have a pH of 2.5 hydrochloric acid, what is the concentration of my hydrochloric acid? So all you've got to do to find concentration right here, here's the one that equals concentration, because these two are our two calculations we're going to be using here. Do I want to find pH or do I want to find concentration? Well, they gave me the pH. That means I have to find the concentration. So let's go ahead and find the concentration now. So what you're going to do is going to go 10 to the negative pH. So you're going to go 10 to the, and you're going to usually open parentheses and put in negative 2.5 close parentheses, and then you're going to hit the equal button. Now here's the important part. This little negative right here, in your calculators, it has to be the negative button, not the minus. You cannot use the minus button. It has to be the negative button. So when I type this in my calculator, let me see if we can get it right here. It's hard with that glare. My calculator has, let me clear it out. If I go to second log, it puts the times 10 to the arrow. So all I got to do is put negative 2.5, close the parentheses, and hit equal. And this is going to give me a concentration of 0.032 We're going to round it to 2. Or we could say 0.003. So this is equal to 0.003 molar HCl. So from that pH, I'm able to calculate the molarity of the acid. Okay, so we did it that way. Another way you could calculate this is you can actually type in 10 and the little up caret right here, and then you got to open the parentheses and put negative 2.5 close parentheses. Remember, we're using the negative button, not the minus button. And if you do it that way, remember we're hitting 10 up caret, open parentheses, negative 2.5 close parentheses, equal, and you'll see we get the same answer. So you need to check your calculator. Do you have that second log button where it gives you the times 10? You see in the green right there it says times 10. Or you might have to manually input it in using the up caret. Either way, you get the right answer. So that's how you do concentration. Now let's reverse this process here. Let's say they gave us a concentration of 0.75 molar solution of sulfuric acid, H2SO4. And they want to know what is the pH? Question mark. So when they give you the concentration, you'll know because you'll have an M next to it. M means molarity. That means they gave me the concentration. And they want me to calculate pH. So you're going to come up here and say, okay, which one of these calculates pH? Well, that's equal to pH. This one's equal to concentration. So I got to use this one. So that means I got to take the negative log of the concentration, right? I got to take the negative log of the concentration. So that means I got to plug in 0.75. That's my concentration. And if I do that on my calculator, it should give me the pH. So let's go ahead and do this now. So we're going to clear this out. We're going to go negative button and then the log button. And it opens up the parentheses for me already. And then I'm going to type in 0.75. And then I'm going to close the parentheses and then hit equal. So this gives me a pH of almost 0. So it's 0.12, and that's my pH. So that's a pH of close to 0. And that means, guys, on the pH scale, how acidic is this stuff? That means this stuff, if you have a 0.75 molar acidity, that's super, super acidic. Okay? So that's how it works. And guys, here's the kicker though. To be able to tell basicness, acidicness, and use this pH scale, you have to be in pH because it stands for the pH scale. No, you can't use any other numbers to determine pH. Only pH can determine pH and do this acid-base stuff. So guys, this is acids and pH. It's actually a really simple calculation, whether you're finding pH or you're finding the concentration from pH. But these are the two examples. If you need to go back, take notes, pause the video, rewind it, do what you got to do to learn this. But this is really, really easy stuff here. So I hope this helps. Acids and pH. Have a great day.
Job's done.